Hello, welcome back. This is Calculus by Dr. Oz. Today we're going to go over two exercises and you are getting exposed to two well-known conic sections. One is a line and the other one is an ellipse. And you will see their parametric representations. And in the first case, you have a line through x1, y1 and x2, y2. And you have this specific form, parametric form, describing the equation of a line. And you have an ellipse with the center h and k, and with a and b. Remember in the description of the equation of an ellipse. So first of all, we're going to eliminate the parameter theta or t, depending on which case you're in. Like in part A, we're going to eliminate the parameter t. In the second case, we're going to eliminate the parameter theta. And you're going to go back to the standard equations of a line and an ellipse. So let's get started.
All right, let's start. So we have a parametric representation of a line through x1, y1 and x1, x2, y2. So we want to go back to the actual xy representation of that by eliminating the parameter t. So to do that, we have to solve one equation for t and plug it back to the other equation. And this strategy may change depending on what kind of parametric form you're dealing with. When you have trig forms, for example, we mostly rely on the Pythagorean identities. But for this type of stuff, all I'm going to do is just try to eliminate, let's say, t from the first equation and plug it back into the second equation, okay? So why don't we subtract x1 from both sides of the first equation so that the left-hand side becomes x minus x1, and then this is still x2 minus x1 here, t times that. And now I'm going to divide both sides by x2 minus x1. Okay, so these guys are going to be gone. So out of this, x minus x1 divided by x2 minus x1 equals t. So this is me solving the first equation for t. And now let's plug this back into the second equation, which is the y equals y1 plus t, y2 minus y1. Okay, so y equals, what do we have here? So y1 plus x minus x1, x2 minus x1, and y2 minus y1. Okay? All right, so let's subtract y1 from both sides. So y minus y1 equals, let's see, so I'm going to write it in a very specific form. So we're going to, in fact, follow the point slope form of the equation of the line. So I'm going to use this ratio to start with. So y2 minus y1, x2 minus x1 times x minus x1. Okay, x minus x1. This form is particularly known because this quantity here is the slope of the line, right? This is the slope of the line, which is in fact rise over run, and rise from where? From the point x1, y1 to x2, y2. So the rise is going to be the difference between the y coordinates, and the run is going to be the difference between the x coordinates, and that takes you to the slope, okay? And this is the point slope form. This is the point slope form of the equation of the line, okay? And I think that's it, right? So this is the point slope form of the equation of the line. That's what the question was asking. There you go. All right. Please watch my next video to see what I'm going to do for part B.